In today's lesson, we'll be learning how to convert factored form to standard form. In a previous lesson, we learned that a quadratic relation is just a type of pattern, and this pattern can be represented with an equation. This equation can be in factored form or standard form. You can convert factored form to standard form using the process of expanding, and you can convert standard form back to factored form using the process of factoring. Today we'll be focusing on expanding. In our first example, we have an equation of a quadratic relation in factored form. We want to convert it from factored form to standard form using the process of expanding. The table to the right is going to help us do that. I'm going to take this x and I'm going to place it right over here. Next, I'm going to take positive 2 and I'm going to place it right over here. Next, I'm going to take the variable of x and I'm going to place it here. And finally, I'm going to take positive 3 and I'm going to place it right over here. We're going to start off by multiplying this term with this term and writing the answer in this empty space. Since we're multiplying terms, that means we're going to be using the product rule. The first step of the product rule is to look at the coefficients. There is no coefficient here and there is no coefficient here, which just means there's going to be a hidden 1. And we like to multiply coefficients. So 1 times 1 is going to give you 1. Next, we want to take a look at the bases. This is a base of x and this is a base of x. Bases stay the same. So I'm going to write an x right over here. And last, we want to take a look at exponents. There is no exponent here and there is no exponent here. That just means there's a hidden exponent of 1 in both of these terms. We like to add exponents. So 1 plus 1 is going to give you 2. I'm going to multiply this term with this term and place the answer in this empty space. First, we want to take a look at coefficients. We already know the coefficient of this term is positive 1. But what about this term? Well, the coefficient there is going to be positive 2. We like to multiply coefficients. So 1 multiplied by 2 is going to give you 2. Next, we want to take a look at bases. We know the base for this term already is x, but what about this term? There is no base over here, but that's all right because bases stay the same. So I'm going to write an x right over there. Last, we want to take a look at exponents. We know the exponent of this term is positive 1, but what about this term? Well, since there is no base, that means there is no exponent. So this 1 has nothing to add to, so that 1 is going to stay the same. We're going to repeat the same process when multiplying this term with this term and writing the answer in this empty space. First off, we want to take a look at the coefficients. Well, we already know this term has a coefficient of positive 1. But what about this term? Well, the coefficient here is going to be positive 3. And we want to multiply coefficients. So 1 multiplied by 3 is going to give you 3. Next, let's look at the bases. We know the base for this term is x, but what about this term? Well, that term actually doesn't have a base, and it doesn't really matter because bases stay the same. So this x is going to stay the same. So I'm going to write an x right over there. Next, we want to take a look at exponents. We know the exponent for this term is positive 1, but what about this term? Well, since there is no base, that means there is no exponent. So this 1 has nothing to add to, so that 1 is going to stay the same. So I'm going to write a 1 right over there. We're going to repeat this process one last time when multiplying this term with this term and writing the answer in this empty box. This should be pretty straightforward since we have positive 3 multiplied by positive 2, which should give you positive 6. I now want to take these 4 terms and rewrite them in this bracket. I'm going to rewrite 1x to the power of 2, 2x to the power of 1. I'm going to add a plus sign in front of it. And then we have 3x to the power of 1. Again, I'm going to add a plus sign in front of that. And we're going to rewrite 6. I'm going to write a plus sign in front of that as well. At this point, you want to look for like terms. Like terms have the same base and same exponent, which means these two terms over here are like terms. When collecting like terms, the bases stay the same and the exponents stay the same. So when I combine this, I'm going to end up with 5x to the power of 1. 1x to the power of 2 hasn't changed, and positive 6 hasn't changed either. Since I have a 2 in front of the brackets, that means I'm going to have to use the distributive property. So everything inside is going to get multiplied by 2. So basically, everything is going to get doubled. So this is going to become 2x to the power of 2. This is going to become positive 10x to the power of 1. And this is going to become positive 12. Let's clean this up a little bit. We don't like to see exponents of 1, so we can erase this one right over there. So we've just converted factored form all the way to standard form.